So these three sets of orbitals are stabilized relative to the dz squared and the dx squared minus y squared orbitals, and they're stabilized by the same amount. So these three orbitals are also degenerate with respect to each other. So then to sort of summarize this set of orbitals, we have for dz squared and dx squared minus y squared, we have large repulsions by those negative point charges. They're pointing directly at the orbitals, and so they're destabilized higher in energy than the other, the dxy, dyz, and dxz. For the dyz, dxc, and dxy, they're smaller repulsion because these orbitals are off axis, and so the negative point charges aren't pointing directly at them. So they're stabilized relative to these guys up here. So that's the whole idea behind an octahedral case of crystal field theory. And we can look at this just one other way if pictures help you. Here it's a little clearer that those negative point charges are pointing directly toward the orbitals. Here I think you can see that the negative point charges are not directly pointing toward any of the orbitals. So I'll show you a bunch of different figures. This all shows you the same thing, but some might help you see this relationship better. Okay, so now we're going to draw some diagrams. I'm going to start over here. So we're going to draw what's called